Okay, in this video we're going to look at the differentiation question in question 4. I'll just go down to it here. So it's this part A and part B. Part A is just little smaller ones. Part B is a pretty nearly a monster expression that I have to differentiate, but we'll just get through them. Okay, just go to new screen. Right, so I'll just take that first one there. Well, not maybe when we yeah, or will we lay out what we? No, we'll take one at a time, right? So I'll take that first one down, and I'll think about it. What do I have? This is the idea with the differentiation. You have to think about what rule you need to use. So the first thing is to say, well, do I need a rule or do I not? It's not. If it's one of the five functions, we kind of wrote this chart up in the partial differentiation video that if I have consider the five functions, e to the box, sine a box. So I'll just kind of do it quickly here again, but if you watch this video you probably don't want to see this again, but I'll just say it very quickly. This is the five expressions that I might get box to a power. Okay, if you have just a simple x in those boxes, then there's nothing to do. You have the answers in the logs tables. But if anything other than just a simple x, you need the chain rule. And as we said, you pretend the box is x and write down what the table says about if the box was x. The table says about e to the box, it would stay as e to the box. Sine comes to cos a box. Cos goes to minus sine a box. Ln goes to 1 over the box, and box to power becomes power box to power minus 1. Okay, but each time you can't not differentiate the box. You have to do that inside expression at some stage. So this is where the saying comes from: ignore the inside, deal with it later. If you want to put it like this, ignore the box and deal with it later. So now you deal with the box each time straight away afterwards. Derivative of box. Now I'm not going to write that 5 times, so write it once, derivative of box, and the idea is that that happens everywhere. So in short, the chain rule is you ignore the box and you deal with it later. So looking at that, we don't have an e to the x, we have an e to the box, if you want to put it like that. Right, so I'll just take that down one more time down here, and I'll say, right, so my function is y equals e to the x, was it x squared plus 3. Right, so that's my box there. And the chain rule goes like this: ignore the box, deal with it later. So the derivative of e to the box is still e to the box. Don't touch the thing, leave it as e to the box. Then multiply straight away afterwards by the derivative of the box. The derivative of the box there, if that purple expression is the box, the derivative of the box is 2x. And leave it like that. So that's just a chain rule in short. Okay, for the next one, I'll take it down again. It's the square root of log of 2x. Right, there's a good bit going. There's 2 chain rules going on in here, but let's just think about it for a minute. So we'll take it down. We'll take it down for kind of freshly down here. Y equals the square root of the ln of 2x. Right, the tip that I always kind of give you is that before you even think about anything, as soon as you see a square root, you must change it to up to the power of a half. So it's that mess on the inside, up to a power of a half. Now, it wasn't the end of the world if you didn't use those brackets there. I suppose you could. It wasn't the end of the world if you didn't do that, but I just think it's safer if you. It would have been safer if you put that whole thing in brackets. Right. What do we have? Right. Well, we still have the business. Do we have? Definitely, we need the chain rule because it's something. It's box up to a power. And not only that there, it's ln of box as well. So there's 2 chain rules coming at us. Right, overall though, it's box to a power a half. this is why you would say, because why it's important to change that square root, because there is no square root in the logs tables. So there's only the five functions: e, sine, cos, ln, and power. E something up to a power. There's no square root of box. You have to remember that the square root of box, it's included. That box to a power includes the three cases of square root of box, because that's box to the half. It also includes 1 over box, well, let's say for example cubed, because you have to change that. You take the box up, but you change the sign of the power. And the very specific case 1 over box as well, it includes that as well. But that's box to the minus 1, because the invisible power there is a 1. So on the top it's box up to the minus 1 when I take it up. Anyway, so box to the power includes those three cases in the red. Anyway, we have box to the half, so I'll say, okay then, so the chain rule goes like this. You ignore the box, you deal with it later. So box to the half becomes take the power down, take 1 off it, and ignore the box on the inside. So there's my half. Leave the box alone and take 1 off a half. I mean, if you're not sure of it, just say, it doesn't matter if you're sure. It's great with these calculators. If you're not sure of anything, just double check it. Minus 1, and I get minus a half. Okay, so there's my minus a half coming at me. Right, now you open up a box and you deal with the box. You open up a brackets and you differentiate the box there. Now unfortunately it wasn't a quick easy answer to that, because I have to start the whole thing all over again now for the derivative of that thing. There's a new box this time, and it's the ln. Within that, okay, well, let's keep the purple box because this is what we're differentiating now. But within that, there's it's ln a box. Try and pick different colours. Ln a box. Right. What does the chain rule say about ln a box? It says that you ignore the box and you pretend it's x, and you say, well, the log table says if it was an x, it'd be 1 over x. So ln a box goes to 1 over box by the derivative of the box. Okay. So ln a box goes to, when I differentiate ln a box, it's 1 over the box. Don't say x, because it's the box, not x. 1 over the box by the derivative of the box, right? The derivative of the box was just a nice simple 2. And I mean, you can, I suppose, just depends on the expression you have, but I think just leave it at that for the minute, I think, because just get the chain rule right. And that's fine then. Right. Okay, the next one, right, unfortunately I have a couple of items going on here. I'll just copy and paste it because I'll not remember that one. I'll take it down here and I'll write it fresh again. There's something wrong there. I think that should be part 3. Anyway, I will not worry about that. Right, so there's a chain rule and a product rule going on here. 1 minus, because there's the brackets indicate, I mean, we're kind of well used to that now. Brackets with expressions inside, and if you were asked to differentiate them, you definitely need the product rule. But one of the terms, you need the chain rule to differentiate it. Right, so I have a first, I have a first and a second expression. So the product rule is the first by the derivative of the second plus the second by the derivative of the first. But for that second expression, I have box up to a power. So I have a lot going on there, but I'll just take my time and I'll get it all done in one go. Right, so again, dy dx, there's something wrong with that corner of the screen. Anyway, dy dx equals the first bracket by the derivative of the second plus the second. Now, I know that the derivative of the second is going to be the most trouble, so I'll just do that there, plus the second. I was right the first time, whoops, sorry, plus the second by the derivative of the first. First by derivative of second plus second by derivative of first. Again, I'm kind of going through this fast now because I kind of took my time saying all this in the partial differentiation video, so maybe watch that first if you're wondering why am I saying first by derivative of second. Anyway, right, so it's the first, there's the first. Again, if you need to write the English words, that's fine as well. First, and this is the second. Right, first by the derivative of the second. So the derivative of the second is what needs the most work. That's box to a power. What do I do with box to the power? I say take the power down, leave the box alone, 1 off the power. There's the box, 2x minus 1. Open up a bracket and differentiate the box then out there. The derivative of that purple box is 2. That's the chain rule for box to the power. Plus the second by the, back to the product rule again, the second by the derivative of the first. There's the second, 2x minus 1 up to the 7 by the derivative of the first. That's just, well, no, there's no x there, so that's a 0, so I'm left with minus 3x squared. Right, that's part 3. Right, they're not too bad, but you need to practice them. The idea is that the video is for, we're doing this video now at the end of the semester, not sort of at the beginning when we were learning this first. When we learnt these, we kind of done these the long way when we learnt these first. You kind of split it all out into U and V and still do that, but I think the idea was that you're comfortable with them now and you're just being tested on them. Do you know the rules overall? Right, so there's a huge amount going on here, but overall, the key is to recognise that overall it's a fraction. But the top, so that means the quotient rule. And again, going through this fast because we took our time with it in the partial differentiation video. The quotient rule in English is the bottom by the derivative of the top minus the top by the derivative of the bottom, all over the bottom squared. However, there's a warning because I see a square root. Before you even do anything, write the square root as a half because it'll just get confusing later. Now I've boxed the power in the top. And on the bottom there's nothing to rewrite there. It's just e to the 5x by sine of 3x. Sine of 3x, yeah. Right. So there's the bottom. And there's the top. Now I'll go with a different colour there because there is the top. But within the top I've boxed the power. And now I just said there's the bottom. The bottom, there's a huge amount going on the bottom. Because I need the product rule, I have a first and a second. And within the second I have sine a box. Right, lot going on, but we'll just stick to our rules and our English sayings and we should get through it. Okay, dy dx. Right, I'll open up all those brackets. Dx. Okay, overall it's the quotient rule. Bottom by derivative of top minus top by derivative of bottom, but I'll leave plenty of space in them brackets. Bottom by derivative of top minus top by derivative of bottom. Now the derivative of bottom won't be that. I mean, the idea is that you'll have to write smaller here because we'll not get this all in, so I'll better write smaller myself. Right, dy dx equals, okay, bottom by derivative of top minus top. I suppose because the bottom I don't do anything, so the second brackets are always the jumbo ones, minus top by derivative of bottom. There we go, that'll give us enough space all over the bottom squared. So in either the product rule, you could say that the first brackets each time don't have to be that large, but you may enlarge those guys so that you fit the derivatives in each second bracket. Right, let's get to it. Right, the bottom by the derivative of the top. Right, there's the bottom, and he's going to be put in there. E to the 5x by sine of 3x. Right, the bottom by the derivative of the top. The derivative of the top is box to the power. Take the power down, take one off the power, ignoring the box term, just leaving the box as it is. As we saw there 2 minutes ago, that's minus a half. When we take one off, a half. Open up a bracket and differentiate the box then. That's just a 2x. Minus the top by the derivative of the bottom. Right, the top, leave the top alone this time, x squared minus 3 up to half by the derivative of the bottom. Right, overall is product rule, so first by derivative of second minus the second by plus the second by the derivative of the first. Right, so within this it's the first by the derivative of the second plus the second by the derivative of the first. Again, you'll have more room in your pen and paper to be doing this. It's just the screen is limited here, and I'm not going to get all in. Sure, okay, so what I'll just do again, I'll just move that expression over in the screen a little bit, and I'll zoom in. Right, there we go there. Okay, first, I'm guilty now of some I think I just, when I was saying first by derivative second plus second by derivative first is the way this is going to go on the bottom there. I think I was using the words top bottom, sorry about that before. Right, e to the 5x, first, there's the first by the derivative of the second. Sine a box, chain rule says it's the cos of box by the derivative of the box. So it's the cos of box by the derivative of the box, which is a little tree, plus first by derivative of second plus second, which is the sine 3x, by the derivative of the first, right? The derivative of the first, final chain rule in the whole thing, e to the box. Right, so that's e to the box stays as e to the box when you differentiate it. This is not going to work out very well. Again, just we're limited in our space here in the screen. Stays as e to the box. Open up a bracket and differentiate the box then at 5. Apologies for the small room I have on the screen here. You'll have more room in your pen and paper. And that's that then. So not quite done yet. That's the complete top line done. And then wrapping up the quotient rule. Again, going back to the very start, what we wrote down first. Bottom by derivative of top minus top by derivative of bottom, which needed a lot of work, all over the bottom squared. So it's just the bottom squared now. That's e to 5x sine of 3x. And we're done there. Thank you.